Hello, and welcome to a lesson on adding and subtracting like terms. So in this lesson, we're going to go over what is meant by like terms and how you would collect like terms. Now, you may have heard the expression, you can't compare apples to oranges. And this expression is kind of applicable um, to collecting like terms. So typically, you can't really add apples and oranges. Okay. However, you can add just if you just have apples. Let's say you have two apples and three apples. You can add them together, and you can get five apples. Now, because apples are like objects, right? So they're very similar to each other. Two apples are fairly similar, and so we can add them together and collect them. To just say it doesn't make sense unless you have different varieties of apples, but it doesn't really make sense to say you have two apples and you have three apples. You would just say you have five apples. Um, Now, when it comes to oranges, you can also add and subtract oranges. So if we have 14 oranges plus 7 oranges minus 5 oranges, we're going to have 21 minus 5, which is 16. Okay, 16 oranges. The reason why we can collect them, why we can add and subtract them, is because they are like objects. They're alike, they're very similar, so we can actually collect them. Um, Now, when it comes to adding apples and oranges, um, you can't actually add apples and oranges. You can add apples and apples and oranges and oranges. So looking here, we're trying to add, looking at example 3, you have 8 apples, 6 oranges. We want to add them, we want to subtract 4 apples and add 10 oranges. Um, so what we can do is we can collect the apples and we can collect the oranges. Okay, so let's start with the apples first. So we have 8 apples minus 4 apples. That would be 4 apples. Now, when we look at the oranges, we have 6 oranges and 10 oranges. We want to collect them. We can just add them because we have plus 6 plus 10, right? So when we add them, we're going to get 16 oranges. Now, notice we're not adding the apples and the oranges because they're not similar objects. They're not like objects. Sure, they're both fruits, but they are different objects, so we can't actually add them and collect those two numbers, the 4 and the 16. So we keep them separate. So let's now talk about when looking at a mathematical term, what that actually means. What is a mathematical term or a typical term in math? So a term in math has a coefficient. So this part here, that would be the coefficient, this number in front. Okay, so that's a coefficient. While what we have beside the coefficient is a variable. Okay, so this part here, and we have talked about variables before already, is called a variable. Now, the whole thing together is a term. Okay, so the entire thing is called a term. So a term has a coefficient being multiplied by a variable. So let's look at how we would determine if two terms are like terms, meaning they can be added or subtracted. So looking at example 1, think about which terms do you think are like terms. Okay, which terms can actually be added or subtracted here? Now, in order for terms to be like terms, they have to have the same variable or variables and the same exponents on those variables. Okay, and so what we can see here is that 7x and 4x, because they have the same variable and the same exponent on that variable, they are like terms. That means they can be collected. They could either be added or subtracted. Now, if we look at the other terms, we don't have anything else that is similar. Because in order for terms to be similar, they need to have the same variable or variables and the same exponents on those variables. And so none of the other terms are like terms. Now, looking at example number 2, think about which of the numbers here, which of the terms here would be like terms that you would actually be able to add or collect or, let's say, subtract from each other. So if you said 4xy and 7xy, then you're right. Okay, they have the same combination of variables, and those variables have the same exponents. So each variable has an exponent of 1. It's just not shown. It's not written. Now notice the coefficients are different, and that's fine. Like terms do not need to have the same coefficient. They just need to have the same variable or variables and same exponents on those variables. Just like the apples and oranges example, right? Oranges could be added or collected together or subtracted, and apples could be added or subtracted from each other. But we couldn't add apples and oranges, right? And notice also that the coefficients are different, right? So even though the coefficients are different, like we have six oranges and 10 oranges, we can collect them still. We can add them and get 16. So coefficients don't have to be the same for the terms for you to be able to collect them. Okay, so some things to remember. Okay, that's important. So a term is made up of a coefficient multiplied by a variable so a variable or variables. There could be more than one, like x and y, for example. Now, so that's a term. Like terms can be collected, meaning added or subtracted. And what you're doing is you're adding the coefficients or subtracting the coefficients when you're collecting like terms. Like terms. Now, like terms can have the same coefficient. Okay, they're allowed to. But the key is for them to have the same variables. So like terms have the same variables and exponents on the variables. Okay, and so those are the key things that you want to remember. Okay, so let's have a look at some more examples. So see if you can do number one, if you can figure out how you would collect those two terms. Now you have to realize that the A actually has a coefficient. Okay, so we have 7a plus a. That a that's on its own actually has a coefficient of 1. Just that coefficient doesn't have to be written. If it's 1, we don't have to write it. So 7a plus 1a is going to be 8a. So those two terms are like terms. They have the same variable, a, and the exponent on that variable is, well, 1. They have the same exponent. So we can just collect them, which means we can add the coefficients, 7 plus 1, to give us 8. And we also write the a. All right, 9p minus p. Okay, so in this case, there is a 1 in front of the p, and we're subtracting. So we just subtract the coefficients, the numbers in front of the variables. So we're going to get 8p. Okay, let's have a look at number 3, which is a little bit more complicated. So first thing you would want to do is you would want to multiply the negative in. Now recall that two negatives back to back make a positive. So 3x minus negative 6y is going to be, so minus 3x is going to be plus 6y. So that's the first step. You have to do that first. And now you look to collect like terms. So you have to identify the like terms. So these two are like terms because they have the same variable. Okay, and also these two are like terms. So negative 10y and 6y. So now we can collect them. So 7x minus 3x is going to give us 4x. And negative 10y plus 6y. So recall that if you're starting at negative 10 and you're going to have to go 6 to the right along the number line to get a less negative number. Okay, so that's going to give us negative 4. So minus 4y. Now the two terms that we have are not like terms because they don't have the same variable. right? 4x has a variable of x, 4y has a variable of y. So we can't subtract them. All right, looking at number 4. This one has a lot of terms. So first thing you want to do is you want to identify the like terms. So recall that like terms have the same variable and they have the same exponent on that variable. So 9x squared and negative, let me make this a little smaller. And negative 6x squared are like terms because they have the same variable, same exponent on that variable. Do we have any other like terms? We do. We also have negative xy and positive xy are also like terms. Now remember, there is a 1 that's just not written, but there is a 1 in front of the xy. So it's negative 1 xy. We also have plus xy. Okay. Now, we also have terms that are not like terms at all. They don't have a, so x and 9y cannot be collected. And they're also not similar to the other terms. Okay, so then what we're going to do, now we can collect the like terms. So 9x squared minus 6x squared, we can subtract the 9 and the 6, giving us 3x squared. And now we're also going to collect the xy's as well. So the xy terms. So negative 1 plus 8. So you're just collecting the coefficients. So negative 1 plus 8 is going to be 7. Right? You're basically taking 1 away from 8. So that's going to be plus 7xy. And now we also write down the other terms. So plus x and plus 9y. They're just there. Okay, now we no longer have any like terms. We can't collect anything. Because notice they have different variables, different exponents. So we just leave it like that. That's the expression in the end. And recall that this is an expression because there's no equality, right? There's no equal sign here. We just have terms being added and subtracted. So that's what an expression is. Okay, so here's some practice questions. So what I would recommend is that you pause the video and take the time to complete them. And then once you are done, you can unpause the video to see how they are done. Okay, so my assumption is that you have completed them already. Okay, so for the first one, they're both like terms because they have the same variable. So negative 3x plus 9x, basically we have to do negative 3 plus 9. So that would be 6x. Another way of adding this, you could instead of adding, you could actually do 9x minus 3x. That works also. Just rearrange the terms if that's easier for you when it comes to working with integers. So you could do 9x minus 3x. That would be fine as well. That would also give you 6x. Okay, for the next one, 2y minus 10y. So you're starting at 2 on the number line and you're going to the left 10 units, right? 10 spaces to the left. So you're going to end up at a negative number. It's kind of like your temperature was 2 outside. It dropped by 10 degrees. Now it's going to be negative 8. So negative 8y. And the next one, so we got -6, and there's a 1 that's not written. Okay, there's a 1 in front of the xy. So -6 plus 1 is going to be -5 xy. Okay, the fourth one, 12y minus y is going to be 11y, and then plus 3. And that's it. You can't collect those two because 3 and 11y are not like terms. -2y plus 7y plus 4. So it's -2 plus 7 is 5. So 5y plus 4. 5x plus 7 plus x minus 9x. So identify the like terms. 5x, x, and -9x. So 5x plus x is 6x. 6x, so we can do this in steps. So we could do 6x plus 7 minus 9x. Now if it helps, you can actually rearrange the terms and write 6x minus 9x plus 7. So you can have the x terms beside each other. Maybe that will make it easier for you to subtract them. So 6 minus 9 is -3. So -3x plus 7. Okay, next one here. Identify the like terms. -8y, -2y, -4y. The terms with the y's. Okay, so -8 minus 2 is -10. -10 minus, so -10 minus 4y is, well, minus 4 is going to be -14. -14y minus 4. Okay, here you would first want to change the two minuses back to a positive. So 8y plus 8y plus 4x. And now we can collect the y's. So 8y plus 8y is going to be 16y. So 16y plus 4x. Okay, next one, 4x plus 4x. It's going to be 8x. 2y plus minus 5y is going to be -3y. Okay, for this one here, 9 minus 3x plus 8y plus 9x minus y. Okay, so I'm going to keep the 9 as it is, just in front. Then we have -3x plus 9x. So that's the same as 9x minus 3x. So 9 minus 3 is going to be 6. So plus 6x. And then for the y's, plus, so 8y minus y is 7y. Okay, so xy plus 2x plus 3xy minus 2y. So we can collect the 1xy and the 3xy to get 4xy. And then the 2x we just write, plus 2x, and then minus 2y. We can't collect those because they have different variables. Okay, and then this last one here. So identify the like terms first. So we got -x squared plus 2x squared. Then we also have so plus 7 and minus 1 are like terms. They're both constants. We also have negative 7x and negative 3x are also like terms. Okay, so now we're ready to collect them. So let's start with the negative x squared and 2x squared. So when we add them, we're doing negative 1 plus 2. That's the same as 2 minus 1. So that's just going to be 1x, or just x squared. Then we can also add, let's now also add the x terms, just the negative 7x and minus 3x. So that's going to be negative 10x when we collect them, because we're doing minus 7 minus 3. So that's going to be negative 10. And then 7 minus 1 is going to be 6. So which is plus 6. And what we have here is called a trinomial. So a trinomial is an expression that has 3 different terms, 3 unlike terms. Okay, we got x squared as a term, negative 10x as a term, and 6 as a term. So 3 different terms that cannot be collected because they're different from each other. Okay, so let's go over expanding, what expanding means. So I'm going to look at some examples. So starting with double of 7. So if we have 7 and we're doubling it, it means we're multiplying it by 2, and that's going to give us 14. So recall when you put a number outside and then brackets and then a number inside, it means you're multiplying the 2 numbers together. Double of 5x plus 3. So what does that actually mean? Okay, so way you can write that is you could write 2 times 5x plus 3. Okay, and then if you expand it or distribute, what that actually means is you're multiplying this 2 inside the brackets. And when you multiply the coefficient. Okay, so the 2 and the 5 get multiplied together to get 10x, and the 2 and the 3 get multiplied together to get 6. Now, is there a different way of doing this? There is. So the double of 5x plus 3 actually means that you take 5x plus 3 and you add 5x plus 3 to it. That's what doubling means, right? If you want to double 2, what do? You do 2 plus 2, right? Or you want to double 3. You can do 2 times 3, or you could do 3 plus 3, right? So if we do 5x plus 3 plus 5x plus 3, we're doubling. And so what does that ultimately become? It becomes 5x plus 3 plus 5x plus 3, okay, which is going to be, if we collect like terms, right, we have like terms, 5x is a like term, and the 3's are like terms that can be collected. When we collect them, we end up getting 10x, so 5 plus 5, plus 6. Okay, so the same thing as what we got before when we distributed. Okay, this is called distributing. Distributing is when you take a number that's outside the brackets and you multiply the coefficients or terms, right, inside by that number. So if you're multiplying 5x by 2, you're just multiplying the coefficient 5 by 2. It becomes 10. And then if you're multiplying 3 by 2, that's obvious, it's 6, right? Okay, that's called a binomial, by the way. So when you have 2 terms, 2 unlike terms being added or subtracted, it's called a binomial. Bi means 2. Okay, so 2 made up of 2 terms. Okay, so let's try another one. So double of 7x minus 5, or 2 times 7x minus 5. How can we write this? We can write it as 7x minus 5 plus 7x minus 5. Right? We're doubling it. So if we multiply the positive into the brackets, that doesn't do anything to the signs. We still just have plus 7x. So plus 7x minus 5. And now we collect like terms. So the like terms that we have here are 7x and 7x. We can collect them to get 14x. Minus 5 and minus 5. If we add them together, we get negative 10. Because we're basically taking away 5 from negative 5, right? So moving left on the number line. And we get another binomial, 14x minus 10. Okay, so when you're expanding, use the distributive property. What that is, so if you have a number outside the brackets, you distribute that number to the terms that are inside the brackets by multiplying everything that's inside the brackets by that number that's outside the brackets. Yeah, so use the distributive property to multiply the numbers or the terms in the brackets by the number or term. It doesn't always actually have to be a number, it could be a term as well. By the term outside. Okay, so let's have a look at these two examples here. So recall that you are multiplying the coefficients by that number outside. So, and you get rid of the brackets. So once you expand, the brackets are gone. So 3 times 5 is 15. Then we also write times xy minus negative 2 times 3 is going to be negative 6. So negative 6x. Okay, so that's called distributing or expanding. Okay. Now, for the next one, for number 5, the same process. You multiply in. You got to do it twice for this example. So 4 times 3, 12, 12x, minus 4 times negative 5, so minus 20, plus 6 times 9, 54, x, plus 6 times 2, 12. And now, this is important, you wouldn't just stop here. You have to always look to collect like terms. And we have like terms. Right, so identify the like terms, 12x, 54x, as well as the constant terms, negative 20 and positive 20. And collect them now. Collect the like terms. So 12x plus 54x. Okay, so 54 plus 12. It's going to be 6 and 6, so 66. 66x. Negative 12 plus, so negative 20 plus 12. is going to be, so you're starting at negative 12 and you're going to the right, okay, on the number line towards 0. So you're going to get negative 8, okay? Another way of doing it is you could do 20 minus 12 and just change the sign to a negative. Okay, so 20 minus 12 is 8, right? But then knowing that, okay, it has to be a negative number since negative 20 is bigger than, well, the number is more negative than 12. So the overall number in the end has to be negative. And that would be it. So 66x minus 8, 66x and minus 8, you can't collect them because they don't have the same variable, right? So they're not like terms. Okay, well, thank you for watching this lesson. And there is a Kahoot activity. So it's just practice questions that I would like you to complete now, just to see what you got from the lesson, to check your understanding of these concepts. All right, well, have a great day, and I'll see you guys tomorrow.